An average human heart beats roughly 75 times a minute, moving a massive 5 liters of blood through your body in that short window. If that muscle simply squeezed all at once, like a wet sponge, fluid would violently mix and flow backward. The entire circulatory system would stall out. Moving that volume of fluid in a single direction requires a flawless hydraulic sequence. This sequence is controlled by the autonomic nervous system and triggered by a built-in electrical pacemaker called the SA node. On screen is a simplified 4-chamber cross-section of a human heart next to a digital timer. To see how this machinery actually works, we are going to slow down time and examine the mechanics of exactly one single 0.8-second heartbeat. Understanding the sequence within this microscopic time loop reveals how the human body prevents fatal blood backflow and keeps you alive. Starting the clock, the first 0.10 seconds is atrial systole. The top atria contract, pushing blood down. AV valves remain open, semilunar valves sealed. Since blood was already dropping passively, this contraction provides the final push, squeezing the last 30% into the ventricles. It acts as a crucial top-off mechanism. The heart ensures its pumping capacity is perfectly maximized right before the heavy lifting begins. Advancing to 0.40 seconds starts ventricular systole, as the thick bottom chambers squeeze inward. Isolating the first 0.05 seconds reveals isovolumetric contraction. The ventricles squeeze, but all valves are locked shut, causing extreme pressure to build rapidly inside the closed space. The sudden pressure spike slams the AV valve shut, preventing backflow. This impact creates the first heart sound, the LUB. With nowhere else to go, pressure bursts the semilunar valves open for ventricular ejection. Exactly 70 milliliters of fluid is violently forced into the arteries. That specific 70 milliliter measurement has a name in biology. It is your stroke volume. This violent 0.3-second squeeze is the direct mechanical force generating the pulse you feel right now in your wrist or your neck. We now hit the 0.40 to 0.80 second mark. The ventricles expand and relax in a phase called ventricular diastole. In the first 0.08 seconds of this relaxation, the internal pressure drops significantly. This vacuum causes the semilunar valves at the bottom to snap completely shut. This acoustic snap is the second sound through a stethoscope, the DUB. During the final 0.32 seconds, ventricular filling, the AV valves reopen. Blood flows smoothly from high to low pressure, pouring passively into the bottom chambers without any muscle contraction. The heart spends exactly half of its 0.8-second cycle completely relaxing and passively resetting. It proves a mechanical truth. Absolute rest is just as biologically vital as the squeeze. The moment that timer hits 0.80 seconds, the sequence instantly loops back to 0 and repeats. This animated equation calculates the total capacity of this system, multiplying the 70 milliliter stroke volume by an average heart rate of 75 beats per minute equals roughly 5 liters per minute. That total volume is your cardiac output. Here is a split-screen chart for a quick exam revision. On the left side, we map the timeline: 0.1 seconds for the atria to squeeze, 0.3 seconds for the ventricles to squeeze, and exactly 0.4 seconds of total relaxation. And on the acoustic side, LUB means the AV valves slam shut, and DUB means the semilunar valves close. Mastering highly complex biological loops for exams like NEET requires precision, exactly like organizing your own study materials. That is where FormReady comes in. You can visit formready.online right now to create custom forms, organize your biology notes, and build the smart study tools you need to boost your productivity and ace your exams.